Okay, guys, we are going to go over some notes on factoring trinomials. So this is a little bit different than the way we did it when we were working in chapter 5. We're not going to use our grouping method this time. This is a little bit of a trick. So if you like factoring by grouping, absolutely continue to do that. But when we have an example like 2x squared plus x minus 10, always, of course, forever, no matter what, we are going to look for a GCF. But there is no greatest common factor in this expression. So our next step is similar to factoring by grouping. We're going to multiply our A and C values together and make a table of values. So what is our A value? Of course, it's a 2. And our C value is that negative 10 right there. We put that in our table. That gives us negative 20. And then you also want to list your B value over here on the opposite side. That's what you guys are used to doing. So let's list our factors of negative 20. We've got negative 5 times positive 4 and positive 5 times negative 4 in our table. Of course, there are other factors, but I'm just showing you this as an example. All right, so negative 5 times 4 does give us negative 20, but when you add them together, you get a negative 1. That's not what we wanted for our B value. Our B value was a positive 1. So let's switch the signs for the 5 and the negative and the 4 and change that to positive 5 times negative 4. We still get negative 20 when we multiply them together, but now when we add them, we get positive 1. So that's step 2. Step 3 tells us to write our two binomials as these expressions right here. Our first one, hold on, let me get my little tool. My first one is going to be x plus our first factor, which was a positive 5. And then we're going to divide by our A value. And the second one is going to be x plus our second factor divided by our A value. And of course, our second factor was a negative 4. So x plus 5 divided by 2. If you'll remember, our A value was 2 times x minus 4, because our second factor is a negative, divided by 2. And then example 4 says simplify the fractions. So 5 over 2, that doesn't simplify, but 4 divided by 2 certainly does. That becomes a 2. And then our last step says if there is still a denominator left over, you're going to swing it to the front of x. So this 2 right here, in our denominator, we swing it to the front of x. So let's actually practice instead of just reading through the steps. And of course, keep that note sheet handy. Our first example says 6x squared plus 7x minus 3. I look for a GCF and I see there isn't one. So I'm going to make my A times C table. So A times C, and then we want the factors to add to make B. All right. Our A value is 6, our C value is negative 3, and when we multiply those together, we get negative 18. Our B value is a positive 7. So let's list out our factors of negative 18. We've got negative 6 times positive 3, positive 6 times negative 3. We could do negative 9 times 2. We could try positive 9 times negative 2, and so on. All right, so here are some factors. We want them to add to make 7. So what is negative 6 plus 3? That gives us a negative 3, not what we wanted. 6 plus negative 3, or 6 minus 3, ends up giving us 3. Again, not what we wanted. Negative 9 plus 2 gives us a negative 7. Hey, that's closer because this is a positive 7, so we need to switch our signs. Change the sign to positive 9 times negative 2. That still multiplies to negative 18, but this time it gives us a positive 7, which is what we wanted. So these are the pair. This is the pair right here that we're going to use to factor. So how do we rewrite? I'm going to put my two empty set of parentheses. My first factor, or my first binomial, is going to be x, and then I'm going to use this 9. So it's a plus 9 divided by, what was my A value? 6. Our second factor is going to be x, and then we have this negative 2 right here, so it's going to be a minus 2 divided by our A value again, which is a positive 6. All right. The next step told us to simplify our fractions. 9 over 6. Both of those are divisible by 3. So we have x plus 3 over 2 times x minus, all right, 2 divided by 6 gives us 1/3. And you can, of course, use your calculator to help you. There we have our fractions. We still have denominators left over. So our last step tells us to take any remaining denominators and swing them to the front. So I'm going to take this 3 and swing it to the front. And this ends up giving us 2x plus 3 times 3x minus 1. And if you want to know why this works, feel free to come in and I will give you a proof as to why it works. If you trust me and you just want to go with it, go with it. It works every time that we have a factorable expression. Let's do, what else do you guys want to do? Let's do example 4. Let's move to example 4. It says 2x cubed minus 30x squared plus 100x. I look at all of those coefficients and I see they're all even. So they're all divisible by 2. Actually, let me move that down a little bit. I know they're all going to be divisible by 2. And I also see that every single one of them has an x variable. And because x to the first power is our smallest exponent, we can factor out only an x to the first power from each of them. So what does that leave us with? So if I factor out our original 2x, can't just make it disappear. It's got to stay out in front. We divided that out. We're left with x squared minus 15x plus 50. So what is our new a value? Our new a value is a 1, and our new c value is 50. So when we create our table, our a times c table, those are the values I want you guys to use, 1 and 50. So 1 times 50, that's a little light, isn't it? I'll switch to black. 1 times 50 gives us 50, and our new b value is a negative 15. So let's list out the factors that we can think of 50. Well, when I see a number that ends in 0, I know it's divisible by 10. So this is the same thing as saying 5 times 10. Let's see if that is what we wanted. 5 times 10 gives us 50, but 5 plus 10 gives us a positive 15. Not quite what we wanted, but close. So anytime this happens to you, I just want you to change the sign of your two factors. 5 becomes negative, and 10 becomes negative. When you multiply a negative times a negative, we do get positive 50, but when we combine them together, negative 5 minus 10 does give us negative 15, and that's the pair that we wanted. So that's what we're going to use. Always, always, always bring down your GCF. Nothing new about that. Now let's rewrite our factors. We have x minus, because our first factor is negative, minus 5 divided by our new a value of 1 times x, and then of course we have our second factor of negative 10, so minus 10 over the a value of 1 again. So we're supposed to simplify these two fractions. Well, 5 divided by 10 is just, 5 divided by 1 is just 5, and 10 divided by 1 is just 10. So our final answer is 2x times x minus 5 times x minus 10. We don't have a denominator left to swing forward, so we're finished. Hopefully that helps.